Welcome to my video on an example of calculating centripetal acceleration. In this case, we're going to look at a car turning a corner. So here's our problem. A car makes a circular turn of radius 200 meters at a constant speed of 60 kilometers per hour. What is the magnitude of the centripetal acceleration? And also, what is the acceleration in terms of g-force? So let's just do a quick review of centripetal acceleration. And our equation for that is going to be centripetal acceleration is going to be v squared divided by r squared, r. Now in this case we've got a circular path. It's for circular motion. There's our radius vector going out from the center. And this is going to be our car right there. The car is going to be going this way with a certain velocity. And so this is the velocity of the car, and in this case the velocity of the car is going to be 60 kilometers per hour, and the radius is 200 meters. So there's our radius, there's our velocity. Now, one thing we do know on the centripetal acceleration, that vector always points towards the center. So it always moves inward, because we have to have a force moving the car in a circle. So that force has to push it inward. Now, we as passengers in a car, we're going to feel another force, a pseudo force, but we're not going to get into that here. But for this video, centripetal acceleration goes inward. And I do have another video I'll put at the end here that explains more of that. But now the next step is we need to convert. We want the velocity in meters per second. So let's convert. So we've got our velocity now is in 60 kilometers per hour. That's equal to 60,000 meters by 3,600 seconds. Dividing that out, we're going to get 16.67 meters per second. So that's our velocity expressed in meters per second. Putting that into our acceleration formula, 16.67 squared divided by the 200 meters. That's going to give us 1.39, and that's going to be meters squared per second squared per meter. Now the meters are going to cancel out, so we're going to get 13.9 meters per second squared. And that has units of acceleration. And like I said, that's going to be inward toward the center. So there is our first problem solved. Got part A. Now, next we want to look at the centripetal acceleration as a g-force. Now we know this g-force acceleration is 9.8 meters per second squared. And that's going to be the acceleration a body experiences at the surface of Earth. Let's do the gravitational pull of the Earth on an object. So let's do some calculations now on that. So our acceleration now, we're just going to do a conversion. So we got 1.39 meters per second squared divided by 9.8 meters per second squared. So that, doing the math, is 0.14, and that's going to be g. This is a unitless number. It's just a ratio of the centripetal acceleration of the car divided by the centripetal acceleration of the Earth. And what this wants to do is we're trying to get an idea if this is a small number, it's a mild turn. If it's a large number, it's a really fast turn, maybe like in a race car or on a roller coaster. So we see that since it's much less than 1, so this is going to be a mild turn in the road. And if you work the numbers out, it's about like what you experience in an elevator. You know, it's just kind of a gentle nudge. Here you go taking a gentle turn. So I want to thank you for watching, and I hope you learned a little bit about how to calculate the centripetal acceleration in an example. Thank you for watching.